students, welcome back. So we are discussing the topic of divide and conquer methods. So let us see the first example of the divide and conquer method, that is the binary search. So what is this binary search and how we will search the element by using this binary technique. So the binary search is an efficient algorithm. So this is an efficient algorithm for searching in a sorted array. So to search an element in an array, so for binary search, the one thing you have to be noted that you have to take only the sorted array. The sorted array, in the sorted array only you can search the element by using this binary search. Okay, so let us see this algorithm. First I'll explain the algorithm. After that I'll take the examples how to search the element in an array by using the binary search technique. So first you have to inspect the middle item of an array of size n. So you have to take a array of size n. So in this size n you have to identify the middle item. So what is the middle item, you have to find out. And the second, inspect the middle of an array of size n by 2. So again you have to find out the middle item in the sub problems. So of size n by 2. So means we are just dividing the array, just divide and conquer method, just like a divide and conquer method, but in binary search you have to take the sorted array. So the main thing is you have to take the sorted array. The array should be in ascending order or descending order. So you have to take that sorted array. So in that sorted array, first you have to find out the middle item, and next for the sub problems also you have to again find out the middle item. And the third, again inspect the middle item of an array of size n by 4. Next is the n by 4, means again dividing into sub problems like that. So in that you have to find out the middle item. So after finding all this and so on until lower bound becomes greater than upper bound. So until the lower bound becomes the upper bound, you have to inspect the middle item of array of size n by 2, n by 4, like that go on. So this implies k is equal to log n to the base 2. So up to this time we have to search for the element. So that is a k is equal to log n to the base 2, where is n is the size of an array and k is nothing but the number of partitions you are doing. Number of partitions. So this is the algorithm for this binary search, means just a simple words. Okay, so after that I'll just explain the pseudocode of this binary search. So in this algorithm they are just explaining it requires an array be sorted first. So rather than for the start at either end, binary search splits the array in half. So rather than going for the start element or the end element, the binary search always splits the array in the half, just like dividing. So dividing the array into halves. So and works only with the half that may contain the value. Suppose if the value, this is a sorted array. Suppose I want the value 5. The value 5 is present in this half. So then the binary search will search only these half only. It ignores the next half, because this is a sorted array. So and works only with the half that may contain the value. This action of dividing continues until the desired value is found. So until the desired value is found, you have to search for the left half. Okay. or the remaining values are either smaller or larger than the search value. Okay, so let me explain the pseudocode for this binary search. After that, I'll explain the examples. Let me write the pseudocode. So I already explained what is a pseudocode in the starting of the subject, starting videos of the design and analysis of algorithm. A pseudocode is nothing but it is a description of what an algorithm must do. Just a description of what an algorithm must do, and also it expressed in the form of expressed in formally styled like natural languages, just rather than programming language. So it's not just like programming language, but it's a formally styled natural language. You can call it as a formally styled natural language. So let me write this pseudocode for binary search. Binary search. So A, start, and key. So key is the item what we have to find out. So first you have to check if start is less than or equal to end. So if start is less than or equal to end means no elements are there, only one element is there in an array. Okay, so start is less than or equal to end means nothing is there. Sorry, if start is less than or equal to end, start is always less than or equal to end. So end will be more. So for array starts from 0, 1, 2, 3 up to n. Okay, this is end. So start less than or equal to end, then enter into this loop statement. Mid is equal to start plus end by 2. So here the start I am taking as 0 and the end, suppose if it is n by 2. 0 plus n, that is n by 2. So it's nothing but it compute the middle element. It's just computing the middle element. Okay. So if key value, so whatever the key, this is a search value. Means whatever we are going to be search value. If key equal to a of mid, so whatever we are divided, so that is equal to key value, then return mid, just simply return mid. So this is a successful search, just return mid, nothing but found it, element is found it, and it should be a successful search. Okay, so whenever we divided the problem, okay, array into half, and whatever the a mid value, that mid value is equal to key value, then just simply returns the mid value. Then you can say it is a successful search. Else if key is less than a of mid, so if the key value is less than a of mid, means left hand side. So the value is present in the left hand side of the array. So if key is less than a of mid, then return binary search start comma mid minus 1 comma key. Okay, so here it recursively call itself for lower part of an array. Recursively called itself for lower part of an array. So just it's recursively calling the lower part of an array. So next, else if key is suppose if key is or else directly return the value. If key is less than a of mid, you have to return this. Else you have to return binary search right side is, so mid plus 1 and key, and close the binary search. So what it indicates? It recursively called itself itself for upper part of array. Okay, or else return -1. So return -1 is nothing but unsuccessful search. Means you didn't find the element in the array. Whatever the element you want, that is not present in an array. So then you call it as unsuccessful search. Close the binary search. So this is the pseudocode for the binary search. So in the next video, I'll explain how we are finding an element in an array by using the binary search with an examples. Thank you.